Okay, continuing on with week 12. And here is another example from Bedford and Fowler. I'm not sure that it's too much different from the one we just did in the previous example, but here it is. It's on paper, so I feel like I got to do it. So this mass, oops, come on back. I keep doing that. I don't know why. We get a mass that's equal to 100 kilograms and a spring constant that's equal to 4 newtons per meter and a damping coefficient of 24 newton seconds per meter, and the base is subjected to an oscillation of 0.2 radians per second. The steady state amplitude of the mass relative to the base, so the mass relative to the base, so this is very much similar to a vibrometer, is measured and determined to be 200 millimeters, right? So in this case, that's going to be the Z is going to be 200 millimeters, because that's they're calling it X, but we have been using Z when it's the relative. What is the amplitude of displacement of the base, right? So they're basically asking for this right here. So we want to find Y. All right, so same procedure we've been using. Omega n is K over M. 4 over 100, so it's likely to be a small number, 0.2 radians per second. We could find critical damping, 2m omega n. 2 mass is 100. Omega n is 0.2. Comes up to a nice even 40. And then now we can find the critical, let's see, we got the critical, that was the critical damping coefficient. We can find the damping ratio of 24 divided by 40, or 0.6, and we can find the R, so omega F over omega N. So omega F is 0.2, omega N is 0.2. Resonance, boom. So we need to I just recognize its resonance. All right, so the equation that we generally will use is Z is equal to Y. I say generally use. When we have the situation where we're doing the relative one, it's the one with the Z in it, and it's got an R squared over the square root of 1 minus R squared squared plus 2 squiggle R squared. But at resonance, a lot of things turn into 1, right? So we could say that we have Y right here, but we have 1 squared, and then square root of 1 minus 1 squared, right? So it all just turns into 0, plus 2 squiggle 1 squared. So what we're left with is 1 over 2 squiggle. I think so, right? Because these things got squared, but then they got square rooted. So we want to try to find, but what we're looking for in this problem, we're looking for Y. So that's going to end up equaling Z times 2 squiggle. So if you take 200 millimeters, multiply it by 2, and then you multiply it by 0.6, you end up with 240 millimeters. And And so that's the prediction that we're going to get. You put in 200, and then the relative between these two is going to be 240. Just a little twist on the problem, not too much different. One more after this. Kaboom.